Hello, this is Mrs. Williams from Tyler Legacy High with another lesson, and today we are going to cover distance. The distance between 2 points is the length of the segment or the line segment connecting them. So I want you to study this number line in these segments. Okay, for segment AK, we see that A is at -2, K is at 4. We want to see their distance. So 1, 2, 3, 4, 5, 6. I went 6 units. Okay. DL. So for DL, I went, let's see, here's D and here's L. 1, 2, 3, 4, 5, 6. 6 units. BJ. 1, 2, 3, 4. Now KD. Here's K and here's D. Let's see. 1, 2, 3, 4, 5. I went 5 units. Now, I went backwards because I started at D, but it doesn't matter. Distance is how many steps you took, how far you went. The negative just means I went back. So I'm not asking for direction, only how many. So distance will always be positive. Okay, BA. So again, from B to A, 1, 2, 3, 4. 4 units. Even though we went back, it's not -4, but 4. Distance is never negative. It's always positive. The negative and the positive tells you the directions, but that's not what we're asking, only what the distance is. So what are we really doing? What process? When you had A and K, you got 6. So let's look at what we did. We ended up at K. So I really want to know the difference between these two. So if I take 4 minus a -2, that does give me 6. And from DL, if I take 5 and subtract -1, I also get 6. And BJ, since start at J, if I go from 6 minus 2, that does give me 4. And let's look at KD. I start at D, and I'm going to, well, I ended up at D, so I will do -1 minus 4 to keep us consistent, which will give me -5. So this is where we come and we insert these symbols. This is called the absolute value. And the absolute value is the number's distance from 0. So it tells me I don't want to know the sign. I don't want to know what direction you went, only how far you went. And what I went was 5 units. In other words, it's always positive. In actuality, we're also taking the absolute values up here. It's just we didn't, since they were positive, we didn't really need to address that. So BA, so A is my endpoint, so it's -2. I'm going to subtract A, let's see, A, -2 minus 2, and that gives me -4. But remember, I don't want the direction that I went, I only want to know how far, and that's the absolute value. So let's apply what we've learned to the coordinate plane. We're going to find the distance between 2 pairs of points. Point J is 2, 3, and point K is 8, 11. So we're going to have 2. Here is 2 and 3. It's right here. And that is point J. And And this one is 811. It's going to be way up here in the corner. And this is point K. And I want to find the distance between these 2 points. Well, we're going to do the same thing. Remember that you can subtract. You want to find the difference if you're looking for the distance. So we have 2 number lines. We have the x-axis, which is our horizontal number line, and we have the y-axis, which is our vertical number line. So I'm going to take this one, and I am going to sort of do this. Let's see what that distance is. On this one, we have 8 minus 2, which gives us 6. Okay? And on this one, we have 11 minus 3, which gives us 8. Okay, so there are our distances. Now, where have you seen this? Think back to 8th grade. So this is more or less the Pythagorean theorem. So to find this length of C, remember that you take a squared, and then you take b squared. This being a, and this being b. Okay, so let's see what happens. A squared plus b squared is equal to c squared. So a squared is 6, gives us 36. Well, a is 6, b is 8, that gives us 64. And we're going to make this distance because that's what we're looking for. We add together, we get 100. Now we're not looking for d squared, we're looking for the distance. And we get the distance is equal to 10. So the distance between these points is 10 units. A squared, taking a and squaring it, b squared, added together, and taking the square root. So let's try another example. And here I have a sample problem. This is going to be x of 1, y sub 1, x sub 2, y sub 2. Here's the distance formula. I'm going to substitute in negative 9 minus 5, and I'm going to square that, plus 3 minus 7, square that. Now, unlike the slope formula, it really doesn't matter that which you pick first because you're going to square. Okay? This is always going to be positive. Negative 9 minus 5 is negative 14, but I'm going to square that. 3 minus 7 is negative 4, and I'm going to square that. So, to conclude, 14 squared is 196. Negative 4 squared is 16. Added together, we get 212. And the square root of 212, the distance is going to be 14.6 approximately. Now, let's try with the graphic organizer. And on this one, I'm going to take the same 2 points, and I'm going to use the vertical method. here's my x, and here's my y. So look at the order of operations. Underneath the radical, you know you have to subtract first, and then you have to square. Parentheses, please, so do what's inside the parentheses. Exponents next, okay, and then you're going to have to add before you can take the square root. So you can use that to set it up like this. First thing you want to do is you are going to subtract, okay? Then you are going to square. Then you are going to add, and then you're going to take the square root. And that is going to give you your distance. Okay? Just another way of looking at it. Negative 9 minus 5, 3 minus 7. Now, you're going to get, right here, you're going to get the negative 14, and you're going to get negative 4. Well, then you're going to square them. That's going to give you positive 16 and positive 16 and positive 196. Okay? And at this point, then I'm going to add those, and that's going to give me 212. Really shouldn't have that there. And then I'm going to find the distance by taking the square root, which is going to give me my 14.6. So a little different way, just depends. If this is a little too much, we can break it up into steps. Either way, we want you to be successful. Good luck. Let me know if you have any questions. Thank you.